All right, today we're going to talk about factoring. We're going to start off with our beginning lesson on greatest common factor and taking difference of squares and sum and difference of cubes. Just to start off, a reminder of some terms. A monomial is a one-term expression. A binomial is a two-term expression. And a trinomial, of course, is a three-term expression. All right, so the first thing we're going to look at with factoring, and it's the first step of any factoring application, is we're going to look for a greatest common factor. Greatest common factor is the biggest number or variable that every term has in common, and whenever we factor a polynomial, it means we're like undistributing or we're dividing. All right, so when we look at 6x plus 9, we think, what can I divide both 6 and 9 by? And of course, I can divide both of those by 3. And when I divide 6 by 3, that leaves me with a 2. That x stays there. And when I divide 9 by 3, that leaves me with a 3. And so that leaves me with 3 times 2x plus 3. And of course, if I were to redistribute that 3 to the 2x, that would leave me with 6x, and 3 times 9, or 3 times 3 is 9. All right, looking at number 2 here, n squared minus 9n. Both of those have an n in common. Okay, so both of those can afford to give up an n. And when I take an n away from both of those, that leaves me with an n minus 9. Of course, when I redistribute, n times n is n squared, n times negative 9 is negative 9n. All right, looking at the number 3, 4x squared plus 8x. Well, they both can afford to give up a 4. Both can be divided by 4, and they both can afford to give up an x. All right, so we got the 4x, and that leaves us with an x plus 2, because 8 divided by 4 is 2. The x's cancel out. All right, last one here. We got negative 14b squared minus 7c cubed. Now, it's very important whenever our leading coefficient is negative, we have to factor a negative out. Even if that's the only thing we can factor out, our first term should never be negative. All right, so we want to factor the negative out. Look at the 14 and the 7. Negative 14 divided by and negative 7, they both can afford to give up a 7. And then the letters, there's nothing in common. One's a b squared, one's a c cubed. B and c don't mix, so there's nothing we can do with the letters. All we can factor out is a negative 7. All right, so negative 14 divided by negative 7 is 2. So still have that b squared. Negative 7 divided by negative 7 is 1, so all that's left is a positive c cubed there. All right, so that does it for greatest common factor. Next, we're going to look at difference of squares. Anytime we have the difference of two perfect squares, difference implies subtraction. They have to be separated by subtraction only. Addition does not work. Only subtraction. We can factor this out into the pattern of the square root of the first term plus the square root of the second term, and then the square root of the first term minus the square root of the second term. So first thing we're going to have to do is go through and make a list of all of our perfect squares. So we got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So those perfect squares are really, you're going to need to memorize those. Those as soon as you're going to need to be able to identify those as perfect squares immediately. Also, perfect squares are any variable that's raised to an even power. Any variable raised to an even power is a perfect square. So x squared is a perfect square. So what I'm going to do is, first of all, identify my a and my b. My a is the square root of the first term, x squared. The square root of x squared is x, and b is my square root of my second term, so 1 square root of 1 is 1. So now I'm going to factor that as a plus b and a minus b, so x plus 1 and x minus 1, and that is my factoring for difference of squares. That's all I got to do. 9m squared minus 1, everything there is a perfect square, so what I'm going to do is go ahead and factor that, or label my a and my b. My a is the square root of 9m squared, so 3m. My b is the square root of 1, which is 1. And I'm going to write 3m plus 1 and 3m minus 1. All right, that does it for page 1. Moving on here to the top of page 2. Had a little bit of issue with the formatting, but we can work with it. We've got to figure out our a and our b first. Our a is the square root of v squared, which is v. My b is the square root of 36, which is 6. So I end up with v plus 6 and v minus 6. All right. Now, 3x cubed minus 27x, none of those are perfect squares, but remember the first application, or the first step in any factoring application is to find a GCF. And I can take a 3x away from both of those, and that leaves me with an x squared minus 9. And now x squared minus 9 is factorable by difference of squares, because my a would be the square root of x squared, which is x, and my b would be the square root of 9, which is 3. So we'll do x plus 3, x minus 3. All right, now, sum and difference of cubes. It's kind of messy, so we got to remember our SOAP. SOAP stands for same, opposite, and then always. And some people say plus here. Some people say positive. It means the same thing. So you can use either one. Always plus, always positive. All right, and what that stands for is the same sign, opposite sign, and then always plus sign, or always positive. All right, and so as we're looking at difference of cubes, we're going to do same, opposite, always plus, and for sum of cubes, same, opposite, always plus. So the signs that we have in our parentheses, we're going to follow that pattern of SOAP. All right, so just like we did with difference of squares, the first thing we're going to do is figure out what our a and our b are. The a is going to be not the square root, but the cube root. What number times itself 3 times equals x cubed? And so that's going to be x, and the cube root of 8 is 2. And so then we're going to make 2 parentheses. First one's bigger than the second, or the second one's bigger than the first one. And then we're going to have our SOAP signs, so same, and then opposite, and then always plus. And then we just plug in our pieces. So a and b go here, x and 2. And then we do a squared, which is really, if you think about it, a times a. So a squared is x squared. Then we do our a times b. So that is going to be 2x. And then we do our b squared, which is b times b. 2 times 2 is 4. And that's all we have to do. That's factored form of that x cubed minus 8. So m cubed plus 64. So our a is m. Our b is going to be the cube root of 64, which is 4. All right, so then we build our parentheses. Same, opposite, always plus. And so then we just put in our a, our b, our a squared, which is m squared, a times b, which is 4m, and then b squared, 4 squared is 16. And that's all there is to it. That is factored form. All right, 8t cubed minus 27. Both of those are perfect cubes, so we need to figure out our a and our b. Our a is going to be the cube root of 8t cubed, so that is going to be 2t. Our b is going to be the cube root of 27, which is 3. Build our parentheses out. Put in our signs, same, opposite, always plus. And so then we had 2t minus 3, and then, so our first one is going to be 2t squared, so we're squaring both the 2 and the t, so that's 4t squared. And then we have 2t times 3, so 6t, and then we have 3 squared, so that is 9. Goes there. Then the last one here, we have 27x cubed plus 125. All of those are perfect cubes, so we can do this. A and B, that's the first thing we've got to identify. A is the cube root of 27x cubed, so that is 3x. B is the cube root of 125, so that's 5. And we build our parentheses, same, opposite, always plus. And then we plug in our pieces, 3x plus 5, and then we square 3x, so that's going to be 9x squared. 3x times 5, so that's 15x, and then 5 squared is 25. All right, so now putting this into practice, 16 into the fourth plus 4n squared. First thing is look for a GCF, so it gives me 4n squared, and that leaves behind a 4n squared plus 1. Anytime we divide something by itself, that's 1, not 0. All right, looking at this next one, looking for a common factor first. I can take out a 5m from all of those, and that leaves behind a 4m squared plus 3m plus 1. And that's as far as we're going to factor right now. And then we got a 9t squared minus 16. Well, all of those are perfect squares. My a would be 3t. My b would be 4, separated by subtraction. So I end up with a 3t plus 4 and a 3t minus 4. And then lastly, I got x cubed minus 125. Well, all those are perfect cubes. So my a would be x, and my b would be 125. So, or sorry, not 125, sorry about that. Just 5, cube root of 125. And we have x plus, or sorry, minus. Let's just build our parentheses out first. All right, so x and 5 go there. This is going to be an x squared. That's going to be a 5x, and that's going to be a 25. All right, that does it for our notes today. If you have any questions, just give me a holler on Canvas or shoot me an email.